Okay, I'm ready, sir.
Hello. Start, sir.
Okay. Good morning, students. Once again, welcome back to our TRICE webinar classes. So this is session ellipse, session 2. So before that, going to class 2, we have to recapitulate what were discussed in the previous class. That is ellipse. What is the standard form of ellipse? That is x square by a square plus y square by b square equal to 1, where a is greater than b and a is less than b also. And here b square value is a square of 1 minus e square. B square value is a square of 1 minus e square. And length of the major axis is, if a is greater than b, then that is 2a. If a is less than b, that is 2b. If the length of the minor axis is nothing but 2b, if that is a is greater than b, if 2a, that is nothing but a is less than b. Okay, so then now we are going to, and also length of the latus rectum is there, that is 2b square by a, where a is greater than b, and 2a square by b, where a is less than b. Okay, so now we are going to class 2, that is find the eccentricity of the ellipse. Find the eccentricity of the ellipse. Eccentricity is nothing but e value, and if its length of the latus rectum is equal to half of major axis. What is asking here? So just find the eccentricity, and if it's length of the latus rectum is nothing but 2b square by a and the half of major axis. So the solution for that one I'm taking, this is what he says in the question, and this is in the standard form. Standard form is nothing but we are taking x square by a square plus y square by b square equal to 1, where a is greater than b. X square by a square plus y square by b square equal to 1, where a is greater than b. Then length of the he given that length of the latus rectum is equal to 2. Length of the latus rectum is equal to 2, half of the major axis. So what is the length of the latus rectum? That is nothing but 2b square by a, and the half of the major axis. What is the major axis? 2a. Half means 2a by 2, which is nothing but a value. So that is 2b square by a equal to 1 by 2 of 2b square by a. This is the length of the latus rectum of the major axis, that is 2a. So then I'm cancellation this 2. So 2b square by a equal to a, and taking into right side this one, you will get 2b square equal to a square. 2b square equal to a square, and we know the value. What is the b square value? A square of 1 minus e square. B square value a square of 1 minus e square. So now I'm substituting there 2 of a square of 1 minus e square, which is equal to a square. Then I'm cancellation a square. So then I will get 2 of 1 minus e square equals to 1. 2 of 1 minus e square equals to 1. Then this value 1 minus e square equal to 1 by 2. 1 minus e square equal to 1 by 2. Then solve this one. You will get e square equal to, I'm taking this e square to right side, this value is left side, and writing reversing that one, e square equal to 1 minus 1 by 2. 1 minus 1 by 2 is nothing but again 1 by 2. That is e square equal to 1 by 2. E square equal to 1 by 2. This is e square value. What we have to find? Eccentricity, e value. That is, e value is e equal to 1 by root 2. Eccentricity is 1 by root 2. So once again, I'm repeating this question. So find the eccentricity of the ellipse if its length of the latus rectum is equal to the half of major axis. So first we know the formula of length of the latus rectum and half of the major axis. Then we can solve from this 2, will get e square value. So where the e square value? So firstly, we know the value b square value, that is b square equal to a square of 1 minus e square. From that one you can solve easily. So then this is a solution for the given question. And next one. So find the equation of the ellipse referred to its major axis and the minor axis as coordinate axis or x-axis, y-axis. So major axis is x and y axis is minor axis with a latus rectum of length. Length of the latus rectum is 4 and the distance between foci. Distance between foci is 4 root 2. So once again, I'm saying that find the equation of the ellipse. Refer to its major axis and the minor axis as the coordinate axis, that is x-axis and y-axis respectively, with the latus rectum length is 4 and the distance between the foci is 4 root 2. So latus rectum formula 2b square. Length of the latus rectum formula is 2b square by a equal to 4. And the distance between the foci. Distance between the foci means it has ellipse has two foci, that is AE comma 0 and S dash I'm taking minus AE comma 0. Minus AE comma 0. Just you have to find the distance between these two. This two you will get. So this is the length. He given that this is the length. So then solve the solution for this one. Let the required equation is I'm taking x square by y square, x square by a square plus y square by b square equal to 1, where a is greater than b. Whether because of x-axis in the question, what is saying that x-axis is the major axis and the y-axis is the minor axis. So I'm taking this one. So length of the major axis depends upon the a is greater than b, a is less than b. If I are taking a is greater than b, I will take that is 2b square by a, which is nothing but 4. And so 2b square equal to 4a, then b square equal to 2a. This 2 will get cancelled for 4, that is b square equal to 2a. So then next, what is given there? So distance between foci is 4 root 2. Distance between foci is s is ae comma 0 and s dash is minus ae comma 0. So then distance formula x2 minus x1 whole square plus y2 minus y1 whole square. Then you will get minus ae whole square plus 0 minus 0 whole square. Then you will get minus 2ae whole square, which is under root. Then you will get this value 2ae. So then you will get 2ae distance between foci. Then what given that in the question, that is the 4 root 2 value. So 2ae equal to 4 root 2. And then just cancel it one. 2 2s are 4. Then ae equal to 2 root 2. ae value as 2 root 2. Then squaring on both sides, you will get a square e square equal to 8. A square e square equal to 8. Then, so we know the value of b square. We know the value of b square, that is b square equal to a square of 1 minus e square from the standard form. Then you will get b square equal to a square minus a square e square. A square minus a square e square. And the value of b square is nothing but here 2a. B square value is 2a. Just I am taking b square replacing as 2a, I will get 2a equal to a square minus a square e square. So a square e square value in the previous we get that one, a square e square value is 8. Then I will substitute there. Then I will get 2a is equal to a square minus 8 and convert into quadratic equation, that is a square minus 2a minus 8 equals 0. Just find the roots of the a from the equation. So then I'm taking a square minus 2a minus 8. So this is, I'm taking this with 4 2s 8 and this is I want to get 2, that is negative 2, and I'm taking this is minus 4 into 2. Then solve this one quadratic equation, a square plus 2a minus 4a minus 8 equal to 0. Then take a as a common from this one, you will get a of a plus 2. From this one minus 4 taking common, you will get minus 4 of a plus 2 equal to 0. And similarly you have to take a plus 2 as common, then a plus 2 of a minus 2, a plus 2 of a minus 4 equal to 0. Then you will get a value as minus 2 and a value as 4. And what we get, we know this from the standard forms, a should be greater than 0. A should be greater than 0. That's why we have to take a value as 4 only. A value as 4 only. Then we can find the value of b square, that is b square equal to 2a. B square equal to 2a. In the first one, that is b square equal to 2 of 4. That is nothing but b square equal to 8. And a square value is 16. A square value is 16. Then the required equation of the ellipse is x square by 16 plus y square by 8 equal to 1. Or this x square plus 2y square equal to 16. This is the solution of the given equation. So just you have to know the what are the formulas included in the question. Just read once question and you will understood easily. Okay. Now we are going to next. So assignment for on this one, previous class and today's class. So if the length of the latus rectum, is equal to half of its minor axis, of an ellipse in the standard form, then find the eccentricity of the ellipse. Today we discussed this type sum in the first term, but in the first question he gave that major axis, here only minor axis. So which means length of the latus rectum, which is nothing but 2b square by a, 2b square by a equal to so 2b square by a equal to, so half of its minor axis in the standard form. Standard form means a is greater than b, it should be 2b. 2b means 2 of b by 2. So this is 2 of b by 2. So then you will get b square, 2b square by a equal to b. You can solve that. b gets cancelled, 2b equal to a. Then you have to substitute the values as b square equal to a square of 1 minus u square. You can solve that one. And for eccentricity. And next question is, if S and T are the foci of an ellipse and B is the one of the minor axes and its STB is an equilateral triangle, so then find its eccentricity. And also this is to find out eccentricity. So what is saying that in the question, so S and T are two foci. This is S and this is T, and two foci, and B is any one of the minor axes. It may be positive, it may be negative, and which is constructed, which is joining these three lines, you will get the equilateral triangle. Then find its eccentricity. So from the equilateral triangle, we know that all the sides are equal. And the values of S, this is in the form of standard form we are taking, that is this value is ae comma 0 and this value is minus ae comma 0. Okay, so then this values we are taking, this is 0 comma b, this is 0 comma b. Then you have to find the lengths, and from that one you have to get in a or b value. Substitute in the b square equal to a square of 1 minus e square, otherwise e square equal to under root of a square plus b square by a square. So you can get the value of eccentricity. Okay, next question. So find the equation of the ellipse standard form, in the standard form, whose distance between the foci and the length of the latus rectum is 15 by 2. So distance between the foci is nothing but 2ae. This value is 2ae. This is 2ae equal to 2. So then you will get ae value is 1, and length of the latus rectum is nothing but 2b square by a, 2b square by a. 2b square by a, which is nothing but 15 by 2. Just solve these two, you will get a value or b value and substitute the given required equation, which is nothing but x square by a square plus y square by b square equal to 1, where a is greater than b. Okay, this is standard form. So next question. So find the equation of the ellipse in the standard form such that distance between the foci 2ae and the distance between the directrix. Distance between the directrix means this value is 32 and this value is 8. Just from the find the distance between the directrix and find the distance between the foci with the directrix coordinates and the foci coordinates. You will get relation between a and b. Then substitute in the x square by a square plus y square b square equal to 1, where a is greater than b. So this is for questions, and next more. So the distance of a point on the ellipse x square plus 3y square equal to 6. So find its center is equal to 2 from its center is equal to 2. Find the eccentric angles. So this is, we have to find the eccentric angles. Just solve that. Distance between the point on the ellipse x square plus 3y square equal to 6. and its center is equal to 2. From its center is equal to 2. Find the eccentric angles. If the length of the major axis of an ellipse is 3 times of length of the minor axis. So what is saying that major axis is 3 times of minor axis, then find its eccentricity. Okay. Then find the equation of the ellipse in the standard form if it passes through the points -2, 2 and 3, -1. So equation of the ellipse in the standard form, that is nothing but x square by a square plus y square by b square if it is passes through the -2, 2 and 3, -1. Just substitute the values in the equation, then you will get a b relation. Solve for a b, you will get a b, then substitute there. So and this question is, I will explain in the later classes. So this is eccentric angles, that is nothing but theta equal to tan inverse of b by a. Okay, so I will explain the later classes. So next one, so various forms of the ellipse. So various forms of the ellipse in the previous parabola. In the previous parabola, we are also discussing what is the various forms of the parabola. So similarly here also we are taking various forms in the ellipse. So how it behave if lies on the x-axis, lies on the y-axis. So that's why you have to know this one. So x square by a square plus y square by b square equal to 1, where a is greater than b is greater than 0. This is standard form. Okay, so x square by a square plus y square by b square equal to 1, where a is greater than b is greater than 0. So this figure like this, please observe this one. So this is an ellipse. So these are directrix x, x dash, y dash, a. So this is the center, and a dash, b dash. This is a z dash. So now I'm going to taking what is the values. So this is a ellipse which is x square by a square plus y square by b square equal to 1, where a is greater than b, which is greater than also 0. So then I'm going to take, this is major axis. What is the major axis of the given equation? So major axis is nothing but x-axis. That is, this is the major axis, a dash. A dash. Major axis is a dash. So similarly, minor axis along the y-axis, like this. This is the minor axis. Okay. Then length of the major axis, distance between the a and a dash, that is 2a. That is 2a. Length of the minor axis, that is the length of the major axis, and the length of the minor axis is 2b. That is this one. Please observe this one. I'm zooming this one. So this green line indicates the major axis. This brown line indicating minor axis. This is the length of the major axis. This is the length of the minor axis. This value, blue line indicating the length of that one. So blue bracket. So that value is 2a, and this value is 2b. Okay. Next. So center is nothing but 0, 0. You are taking with this is 0, 0 as a center, and so foci is nothing but S. It has ellipse has 2 foci, that is S AE, 0, and the S dash is minus AE, 0. So that is S dash. Okay. So then I'm going to equation of the directrix. Equation of the directrix is nothing but x equal to a by e from the standard form. We know the values. This value is a by e. This value is minus a by e. So then eccentricity E equal to a square minus b square by a square. Sorry, in the previous mistake. So here eccentricity is a square minus b square by a square. A square minus b square by a square. So this is the various forms, and that is the first form, which is nothing but x square by a square plus y square by b square equal to 1, where a is greater than b is greater than 1, and the major axis is along x-axis, minor axis is along y-axis. Length of the major axis is 2a, length of the minor axis is 2b, and the center, which is 0, 0. The foci is s, ae, 0, s dash minus ae, 0. And equation of the directrix are x equal to a by e and x equal to minus a by e, and the eccentricity is e equal to under root of a square minus b square by a square. Okay. Once again, I'm zooming this one. So please observe this one. Okay, next. Here we are taking A is greater than B. And now we are going to take A is greater than B is greater than 0, and this value which is I'm taking, sorry, it's a mistake is there. So this is B is greater than A, and these both are greater than 0. So that is x square by a square plus y square by b square equal to 1. B is greater than a is greater than 0. Then so the ellipse lies onto y-axis. In the previous, that is lies on the x-axis. So then, so both actually both axes. So with respect to we are taking respect to that one. So observe this figure. So here, similarly, major axis. In the previous, that one x-axis is the major axis. Now in this one, there is y-axis. This is the major axis along the y-axis. The minor axis along x-axis. So that is this one. And the length of the major axis is nothing but 2b. Here 2b. Why? Because of 2b is 0. B value is 0 comma b, and my b dash value is minus 0 comma minus b. So then length of the minor axis is 2a. Length of the minor axis is 2a. So then next, so center is 0 comma 0, and foci are S is 0 comma be, and S dash is 0 comma minus be. So this is S, and the focus which is lies in the positive positive, and this is negative one. Okay. So equation of the directrix equal to x equal to b by e. So this distance is minus b by e. So equation eccentricity is nothing but E equal to b square minus a square by b square, where a is less than b. Where a is less than b. Okay. So this is major axis is along with y-axis, minor axis along with x-axis. Length of the major axis is 2b. Length of the minor axis is 2a. Center 0 comma 0. Foci 0 comma be comma 0 comma minus be. Equation of the directrix equal to x equal to plus or minus be. Our eccentricity is under root of b square minus a square by b square, which is a is less than b. So now observe this one. So this one. Okay, students. Next. So discussed with the center 0 comma 0. Now we have to going to discuss with the center h comma k. So now if the center lies at 0 comma 0, if I'm taking center not at the origin, so from the transformation of axis or the changes of axis of the first year 1b textbook 1b, so change of axis, which means the center changes to 0 comma 0 to h comma k. So center changes to 0 comma 0 to h comma k. That is, the equation can be written as x minus h whole square by a square plus y minus k whole square by b square equal to 1, which is 0 is less than a is less than b. So this figure, these two, this is x-axis, this is y-axis, and the center is c 0 comma 0. Now center transform from 0 comma 0 to h comma k. So observe this figure. So now this is, so this is a other center, transformed center, that is c h comma k. So then this is the ellipse, so which is lies on the x-axis I'm taking. So these two are directrix, a dash, b dash, z dash, and now I'm taking, so then major axis here, major axis, sorry, so major axis, which means lies on x equal to k, which means lies on x equal to k. X equal to k, is it? So this is wrong. So x equal to h, y equal k here. So this is x equal to h, and this is minor axis along x equal to h. This is also wrong. This is y equal to k, just interchange it. So typing mistake, sorry. So then now, so along length of the major axis is 2a. Length of the major axis is 2a, and length of the minor axis is 2b. So then center h comma k, and thus foci is foci. Observe this one. Foci in the previous one ae comma 0. Here h plus or minus ae comma k we are taking, that is 1 1 plus 1 is here and the minus 1 will be here. Okay, this is h plus or minus ae comma 0. Then first one I'm taking s ae comma s value h plus ae comma k, s dash is h minus ae comma k. So then, so equation of the directrix, that is x equal to h plus or minus a by e, h plus or minus a by e, and next eccentricity is a square minus b square by a square, which is under root where a is greater than b. Okay, this is also wrong one. So a is greater than b here. So sorry for the mistakes. So major axis is along with x equal to h, minor axis is y equal to k. This is y equal to k, x equal to h. Okay, so then sorry, next this is with the x-axis. Now we are going to y-axis. Same. So observe this figure. So previously if you have to observe this figure, so just I'm doing this is the figure. So y, this is center, transform to h comma k. Okay, next one. So this is same as usually, we're here different one. So then, so which is lies on the y-axis, the equation the ellipse like this diagram. So center 0 comma 0, center h comma k, transform to center h comma k. So then major axis, minor axis, so a dash, b dash. So I'm taking, this is directrix. So I'm going to take as major axis as here differently, right, in this one. So this value, so major axis is x equal to h here, and the minor axis is y equal to k, y equal to k. And please refer once I'm taking. So major axis, minor axis, and so this is length of the major axis is 2b, length of the minor axis is 2a. So center h comma k, and foci h comma k plus or minus be, and equation of the directrix y equal to k plus or minus b by e, and eccentricity e equal to b square minus a square by b square. So this is the figure. This one. Okay, now we are going to another one. So we have to solve, find the eccentricity, coordinates of foci, length of latus rectum, and equations of the directrix of the ellipse. Just we have to find the all these values: eccentricity, coordinates of foci, length of latus rectum, and directrix of the ellipse. So which is the given equation is x 9x square plus 16y square minus 36x plus 32y minus 92 equal to 0. The most important and repeating for IPE, this question. So then solution. So given ellipse is this one, 9x square plus 16y square minus 36x plus 32y minus 92 equal to 0. Then I'm taking x values aside and the y values aside and solve for this one. So this one I'm taking here, taking 9 common. So then you will get x square minus 4x. From this one 16 common, y square plus 2y. I'm taking this into right side, then 92 I will get. Then here this is in the form of a square minus 2ab. So we have to complete the square. So completing square method we have to do here. Similarly here also. Then we'll get. So just here x square minus 4x plus 4 minus 4. I'm adding plus 4 minus 4. There is no change, and this will be going to under completing square method. Similarly here also 1 minus 1 I'm adding. So then I will get y square plus 2y plus 1. This is nothing but y plus 1 whole square. Then the equation like this: 9 of x square minus 4x plus 4 minus 36 plus 16 of y square plus 2y plus 1 minus 16 equal to 92. Then, so this value, this is x minus 2 whole square and this is y plus 1 whole square. Then 9 of x minus 2 whole square and 16 of y plus 1 whole square. I'm taking these two 36 and 92 values into right side. I will get this one 92 plus 36 plus 16. This value is nothing but 144. And now I'm going to take divide with the 144 of the total equation. Then I will get 9 of x minus 2 whole square by 144 plus 16 of y plus 1 by 144 equal to 1. Then 9 16 is nothing but 144, 16 9 is nothing but 144. Then I will get x minus 2 whole square by 16 plus y plus 1 whole square by 9 equal to 1, where just compare with the equation of x minus h whole square by a square plus y minus k whole square by b square equal to 1. Then comparing with x minus h whole square by a square plus y minus k whole square by b square equal to 1, then I will get h value as here the h value is 2 and the k value is minus 1 and the a square value is 16, which means a equal to 4 and the b square value is 9 and the b value is 3. So this is the solving. So now just we have to find the eccentricity. So we are find the h comma k value and the a and b values. Then we have to find the eccentricity, center of coordinates of the foci, length of the latus rectum, and the equation of the directrices of the given ellipse. For that one, we have to know what are the formulas first. So then h value is 2, k value is minus 1, a square equals 16, b square equal to 9. Then we'll get a equal to 4, b equal to 3. Here, what is a is greater than b? So if a is greater than b, we can substitute one formulas. If b is greater than a, we can substitute other formulas. Thus, that you have to must know that if a is greater than b or not b is greater than a, then you can substitute. Then, so if a is greater than b, that values of eccentricity is nothing but a square minus b square by a square, which is under root. That is a square value is 16 and the b square value is 9 by a square value as 16. Then 16 minus 9 by 16, which is under root, that is nothing but 7 by 16. This is under root. So then we can get root 7 by 4. That is the value of E. That is nothing but eccentricity of the given ellipse. And so foci is nothing but h plus or minus ae comma k. So this is with where a is greater than b. If a is less than b, h comma k plus or minus b is the foci for the respective ellipse. So that is the difference between if a is greater than b and b is greater than a. That is h plus or minus ae comma k. Then h value is 2 and plus or minus 4. A value is 4 and E value is root 7 by 4. I'm writing like that one. So and the k value is minus 1. Just substitute that one. Then you will get foci is 2 plus or minus root 7 by minus 1. Oh, sorry. So 2 plus or minus root 7 comma minus 1. So these two will get cancelled. We'll get the foci as 2 plus or minus root 7 minus 1. So similarly, we have to find the length of the latus rectum. So this is length of the latus rectum means, so this is a is greater than b. A is greater than b. So then that will be 2b square by a. If length of the latus rectum a is less than b, then 2a square by b. 2a square by b. Then you will get b square value as 9, a value as 4. Then you have to cancel this one, 4 2's. Then you will get 9 by 2 is the length of the latus rectum. Then next equation of the directrix, that is nothing but x equal to h plus or minus a by e. If a is greater than b, if a is less than b, then y equal to k plus or minus b by e. You will get the directrix of the equations of directrix. Then just substitute the x value, y h value and the a value, e value. Just substitute the values. X equal to h value is 2 and the a value is 4 and the e value is root 7 by 4. I'm writing 4 by root 7. That is nothing but taking LCM as root 7. You will get root 7 x equal to 2 root 7 plus or minus 16, which this is a equation of the directrix. Okay. Next. So find the length of the major axis and the minor axis, latus, rectum, eccentricity, coordinate centers, foci, the equation of the directrices of the ellipse. So 4x square plus y square minus 8x plus 2y plus 1 equal to 0. Then solution for this one, just we have to change the equation into x minus h whole square by a square plus y minus k whole square by b square equal to 1, which is a is greater than b or a is less than b. Then you will get and solve for the given in the question. So next, so first given ellipse is this one, 4x square plus y square minus 8x plus 2y plus 1 equal to 0. Then 4x square minus 8x plus y square plus 2y plus 1 equal to 0. Just you have to do here as a completing square method. For that one, first you have to do 4 taking as a common, you will get x square minus 2x plus y square plus 2y plus 1. Then you will get this, just you have to add in the plus 1 minus 1. This is 4 of x square minus 2x plus 1 minus 1 plus this value is nothing but y plus 1 whole square. Then substitute, then simplify that one, 4 of x square minus 2x plus 1 minus 4 plus y plus 1 whole square equal to 0. Then 4 of x minus 1 whole square plus y plus 1 whole square equal to 4. So this 4 taking into right side you will get, but this is negative value, taking into right side values it is positive. So then divide with 4 you will get, then this one is 4 of x minus 1 whole square by 4 plus 5 plus 1 whole square by 4 equal to 1. Then so x minus 1 whole square by 1 plus y plus 1 whole square by 4 equal to 1. Just to compare with the x minus h whole square by a square plus y minus k whole square by b square equal to 1. Then here comparing with this one, then you will get h value as 1, h value as 1, k value as minus 1. So this is k. So k y minus k whole square. Then this is k value as minus 1, a value as a square value as 1, b square value as 4. Then here clearly visible that 1 is less than 4. So which is means a is less than b. So we can apply different formulas. So different formulas. So that is, so now we get h equal to 1, k equal to minus 1, a equal to 1, a b square equal to 4, then b equal to 2, and a square value also 1, a value also 1. Then center is h comma k, that is 1 comma minus 1, and eccentricity e equal to under root of b square minus a square by b square. Why? Because of this b value is greater than a, that's why I am taking b square minus a square by b square. Just b square value, a square value substitute in the eccentricity, then you will get under root of 4 minus 1 by 4, that is equal to root 3 by 4, that can be written as root 3 by 2, which is value is eccentricity. So that is e equal to root 3 by 2. Then foci is nothing but h comma k plus or minus be, that is equal to h value is 1, k value is minus 1, plus or minus b value is 2 here, b value, and the e value is root 3 by 2. That's just you have to cancel this one, then you will get, so this value is 1 comma minus 1 plus or minus root 3. So this is the foci. So next, so length of the major axis is 2b, that is nothing but 2 of 2 is nothing but 4, and the length of the minor axis is 2a, that is nothing but 2 of 1 is nothing but 2. Length of the latus rectum is nothing but 2a square by b. Here 2a square by b, length of the latus rectum. Here this is mistake, this value is 2a square by b, 2a square by b. Why? Because of b is greater than a. Just 2 of 1 by b value is 2, that is value is nothing but 1. Okay, now eccentricity, equation of the directrix are y equal to k plus or minus b by e. Then just substitute the k value, b value, and e value, then solve that one. You will get y equal to minus 1 plus or minus 4 by root 3. Okay, this is a solving for given question. So now assignment for today. So this is find the eccentricity and the coordinate axis of foci, length of the latus rectum, find the equation of the directrix of the following ellipses. So then that is 9x square plus 16y square equal 144. Just you have to transform this equation, x square by a square plus y square by b square equal to 1. Then just you have to divide with the 144, you will get x square by 16 plus y square by 9 equal to 1. Just to find the given values. So then this is also 3x square plus y square minus 6y minus 2y minus 5 equal to 0. Just you have to do completing square methods based on that one. So then you will get the required answers. And this one is a different one, x square plus 2y square minus 4x plus 12y plus 14 equal to 0. Just solve the equations. Now, so find the radius of the circle passing through the foci of an ellipse 9x square plus 16y square equal to 144. What is given that, where is this? Okay, so ellipse like this. So passing through foci, which means here one foci and here is one other foci, and a circle form like this. So like this, just we have to find the radius of this circle. So which means just distance between the two foci, that is 2a. So half of that one is nothing but radius of the circle. Half of that one is nothing but radius of the circle. Just you have to do that. Next. So this is the class today. So in this class we are discussed various forms of the ellipse. So various forms of the ellipse, if the a is greater than b and if b is greater than a, so different formulas will occur. So and also some problems on the previous classes, that is major axis, minor axis. So and this is the class for today, and do the homework, do the assignment. We'll discuss tomorrow's class, the class 3, session 3 of this one, ellipse. Thank you, madam. Hello. Hello. Kashinath sir. Kashinath garu. Kashinath garu.
Sir, cheppandi.
This is end of the class today, madam.
Okay, sir. Okay, you can wind up, please.
Okay, okay.